Hey there and welcome. For this video, we are going to be talking about solving multi-step equations with variables on both sides using the box method. Let's go ahead and get started. All right, so multi-step equations tend to take 3 or more steps to solve. That's because there are multiple steps to them. So this can look like a variety of different ways on how you choose to solve them. We are going to look at 3 different methods to solving multi-step equations. Those are the traditional method, the hanger method, and the box method. For this video specifically, we are going to look at the box method. Now, when you go to solve a problem, I want you to choose whichever method works best for you. And that can change based on how frequently you've practiced the problems, or how comfortable you are with a specific method, or even what the problem itself looks like. And that's okay. Choose whatever method works best for you and your learning style. These problems are also just sample problems of a multitude of problem types that you could possibly see in the next few years of school. So I'm not going to be able to show you every single possible way to solve these problems, and that's okay. But it's a starting point. Once you get the hang of how to do these problems, you'll be able to figure out the rest from there. So let's look at this first problem here with the box method. 6r plus 7 equals 13 plus 7r. So the way that the box method is going to work is that we're first going to have to do our setup. So we're going to draw a line down our equal sign that separates the two halves of our problem. All right, we have the left side and we have the right side. And one of those sides is very specifically going to be variables, and one of them is very specifically going to be your constants. And it doesn't matter which one you make which, it's completely your choice. You're going to notice that up here at the top, I have 2 boxes and then 1 rectangle that connects them. And then 2 boxes and 1 rectangle that connects them. And that's because I have 2 variables. So 2 boxes for those 2 variables, and then I have 2 constants. So 2 boxes for those 2 constants. And then those long rectangles at the bottom are where I'm going to combine those together. So let's actually look at it in practice. So in that first box, I'm going to put my 6r in there because that's the box that I'm going to deem is where my variables are going to go. Now the other variable I have is that 7r, but you'll notice that when it moves to the other side of that line, separating my problem in half, it changes sign. Right here, it started off as a positive 7r, but when I put it in the box, it's now a negative 7r. We had to use inverse operations to get it to that other side. When I combine those, 6r and negative 7r, I end up with negative 1r. Going to do the same thing on the other side here, only with my constants now. So first I'm going to fill this box up with that negative 7. Again, we crossed the line, so our positive 7 has to change to the opposite and become negative 7. And then a positive 13. Negative 7 and positive 13 give me a positive 6. So I end up with the problem negative 1r equals 6. And a lot of people want to stop here, but we're not actually done with the problem. Remember, we're trying to solve for r, not negative r. So we have to divide both sides by negative 1. Negative 1 divided by negative 1 is a positive 1. So positive r, or positive 1r, equals negative 6. We can go through, we can check our answer. We get negative 29 equals negative 29, so we know that we are good to go. All right, for this next problem here, I've got 2 variables on one side, 1 variable on the other. So the setup's going to look a little different this time, and that's okay. I'm still going to separate my problem in half by drawing that line down the middle of my equal sign. I'm making this side, the one on my left, the one with my variables, just because visually that's where we're used to it being. And then over here on the right-hand side, we're going to have our constants. This time you'll notice I have 3 boxes up top because I have 1 variable, 2 variable, 3 different places that a variable shows up in my problem. So I need to have a box for all 3 of those variables. I'm going to place my negative 7x here, my negative 3x here, And then remember that when we transfer over that line in the middle, we move from one side of our equation to the other. We have to take the opposite sign. So that negative 8x is going to turn into a positive 8x. So now I have negative 7, negative 3, positive 8. They're all like terms, so I need to combine them together, and I end up with negative 2x. I'm going to do the same thing on the other side now with my constants. So it was a positive 2, but I transferred it over the line, so now it's negative 2 and negative 8. When I combine those together, I end up with negative 10. So I now have the problem negative 2x equals negative 10. I can really say that negative 2 times what number equals negative 10? And the answer to that problem is 5. Negative 2 times 5 equals negative 10. So I know that x equals 5. If you really weren't sure, you could also divide both sides by negative 2, and you get negative 10 divided by negative 2, which is also a positive 5. So now we can check our answer. We get negative 48 equals negative 48 on both sides, so we know we're good. All right, now in this lesson, we learned how to solve multi-step equations with variables on both sides using the box method. Until next time, I will see you later. Love you, bye.